Good morning, everybody. Are you awake? All right, to prove that you are awake, we're going to take a stage selfie, and you need to scream like you're really excited, all right? So wave and scream. I'll count down from 3, and then we'll all wave and scream. 3, 2, 1, wave and scream. Oh, let's do that again. I told it to not use a flash. All right. Wave. All right. So my name is Peter. I'm a developer relations engineer at Google, and now you might be wondering, why hasn't he started the presentation yet? Why is there Claude? And you'll see in a moment. Also, because there was nobody here to introduce me in person, I'll just get some help here. Always think before you do something. And hopefully the Wi-Fi holds up, because there will be a couple of demos in this talk. So let's see how this goes. It's not going well. All right, let me see. Oh, there we go.
Please welcome to the stage Peter Fries, Staff Developer Advocate at Google Firebase. Peter's here to show us how to connect LLMs to existing tools using MCP, complete with a live demo of an agentic app in action. Let's give him a warm welcome.
Thank you very much. And now let's see if this... No, it does. It's still thinking. Okay, I'll do it myself.
Of course. Let's do this.
All right, so this talk here is about the Model Context Protocol and how to use it in your own apps, and how to use a framework that's called Genkit to build MCP servers and MCP clients. So, as I mentioned, my name is Peter. I live in Hamburg. I work at Google. I'm a developer advocate / developer relations engineer on the Firebase team. I'm also a big iOS fanboy, and that's why I build tutorials like this one that teaches you to use SwiftUI and Firebase. Also, how to use SwiftUI to build reusable components. I record lots of videos that you can see on the Firebase channel on YouTube. I have a live stream on my personal channel where I show how to build a second brain app. And there is a newsletter as well. And here is your first QR code for the day, and you please better scan that, because I just smashed an avocado for that. All right. Also,
our networks in here are always unpredictable, so they're a little, I have no idea what we're going to find. They are slow today. You know, you could help me out if you're on Wi-Fi, if you could just get off. I'd appreciate it.
All right, so I recorded all the demos, so we should be safe. What is the problem? So the problem is LLMs are great. You can do lots of things with them. So for example, if I was a tourist in Hamburg, I could say, give me the top 3 sites in Hamburg, but please be concise. And then I would get the Elbphilharmonie, Speicherstadt, and Miniatur Wunderland. But if I asked stuff like, will my flight be on time? I would get an answer that's probably more like this. I can't access real-time flight information on personal travel details. To check your flight status, please provide me with the airline and flight number, and so on and so forth. Or if I say, I'm traveling to the UK, to a specific place? Can you tell me, I read a book about that place a while ago. Can you tell me what that is? Then the model will also say, well, that's an interesting question, and I can't answer that because I don't have access to your personal data to look into your reading history, for example, or where you travel to. And the reason why that is that LLMs are trained on public knowledge, and thankfully they're not trained on our personal knowledge, and that is why they have limited access. But sometimes you do want to get access to enterprise data, for example, to get recommendations for, I'm looking for a gift for my niece, and give me a recommendation for someone who's 10 years old, for example. Or you want to tap into your personal knowledge data, right? So you have nodes and you want to tap into those nodes to find out, I heard something interesting in the talk yesterday. Can you please find all my nodes that relate to that? And going beyond that, you might even want to tap into any APIs that provide additional services to enhance the power of the LLM, or even tap into apps that run on your local device. And there are ways to do that, right? So to access enterprise data and the user's data, we can use a technology called retrieval augmented generation, and I'm going to show in a minute how this works. And also for accessing APIs and apps that run locally, there is also a way to access that, and it's called tool calling or function calling. And I'm also going to show how that works. So let's look at this first. We've got enterprise data, so for example, a product catalog, or we've got personal user data, for example, your notes. So the user issues a query, and we use that query to look into our index. And once we find relevant documents in our index, we can use those documents and inject them into the prompt. And the prompt might say, here is the user's question. Please use the following documents to answer the user's question. And then, some flavor around that, be funny, be witty, or be just, be concise. And that will be sent to the model, and then the model will generate an answer. So this is retrieval augmented generation, and we've heard it before, and it's a great technique. So what about, will my flight be on time? So when I issue that query to the model, I need access to a bunch of additional APIs. So first of all, I need access to flight data. I also need access to the user's calendar, and surprisingly, I also need access to a clock, because models don't know about the time. So how do we solve this? Well, tool calling. And that enables us to connect the model to all those APIs. So let's take a look at how you can implement this with Genkit. But before we go into how to implement tool calling with Genkit, let me give you a brief rundown of what Genkit is. So who here in the room knows what LangChain is? All right, a couple of you. So usually lots of people know that. Genkit is like LangChain in that it is an AI integration framework. It makes it easy to connect different tools and services that you need in order to implement AI applications. And Genkit is specifically made for apps that run on the backend. You can deploy it anywhere, so it's not tied to any Google technology at all. It does work really well with Google technology, I'll say that. But you could even deploy it on a Raspberry Pi if you wanted. We support 3 different languages. Node.js was the first we supported, but we also support Go and Python. And as I mentioned, it also works with non-Google technology. So it has a wide range of models that it supports. Gemini and Imagine are Google models. And then we support OpenAI, Anthropic, xAI, DeepSeek, and Ollama out of the box. And if you want to connect any other model that you can't connect with one of these, you can even provide your own plugin to extend Genkit. And that applies to literally everything in Genkit. It has a pluggable architecture. You can bring your own stuff, and it's pretty straightforward how to do that. So there are a couple of really exciting features about Genkit. The most exciting one is that it has a unified model interface, and I'll show you what that means in a moment. It also allows you to compose workflows. So you can think of a workflow as something that you want to execute, and you have input data, and then there is output. And that can be AI-related or non-AI related. You could use those workflows to call any API that you might imagine. But usually, at one point, there will be a model involved. And you can plug those workflows together. And there is a number of really amazing tools that support it. For example, there is a developer UI that makes it easy to inspect your flows and see what's going on under the hood, and you can see exactly which information was sent back and forth. Here you can see a screenshot of the developer tool. But let's look at some of the features here. So we are at code.talks, so we are looking at code. First of all, here is how you implement a really simple Hello World application in Genkit. So first of all, we need to import Genkit. Then we're going to set up our AI instance. And we are going to use Gemini 2.5 Flash. And then we can call ai.generate. It's an asynchronous call because it goes over the network, so we'll have to await it. And then we'll just send in our prompt. This is a text prompt, but you can send multimodal prompts as well. So on the Genkit homepage at genkit.dev, there are tutorials that show how to analyze a PDF file and chat with a PDF file, or how to analyze a YouTube video and chat with a YouTube video. So you can use stuff like, point it to the recording of this talk here, and then say, go to the point where Peter shows the first QR code, and it will go exactly to that moment in the beginning of the presentation. So here is the response that we get back. So we destructure it, we get the text, and then we can log it. So I mentioned Unified Model API, and here is how that works and what it means. So this is the same code I just showed you. Now let's replace all the stuff that is Gemini related and use OpenAI. So it's literally just importing the OpenAI plugin, setting up the plugin, and then telling Genkit we want to use this model now, and all the rest of the application can stay the same. And please imagine that this is, you're working on a much more complicated application than this. So it's really cool that you don't have to update all your code, but you can just swap this out, and then you can experiment with different models. Yep. Okay. So another really cool feature of Genkit is flows. Flow. A flow is a special function, so it's like a JavaScript function or a Python function or whatever, and it wraps. Here it says AI logic, but it can be any sort of logic. So key features are, it is type safe. So you specify what kind of data you will pass in, and you can even specify stuff like, I'm passing in a string, and you need to verify that the string has a minimum length and a maximum length. You can also specify the format of the output, so that when the flow finishes and the result will be returned, we can perform additional runtime type checking to make sure that the data is actually in the format that you expected. Obviously, it supports streaming, which is important for AI to get this sweet animation. It has integration with our developer UI, and it also has traceability. So if you use a cloud platform and you want to inspect what's going on in my application, you can use those traces to see exactly what happened, how long did each call take, and what was the data that was being passed around. That's really, really cool. And easy deployment. It's just a regular Node or Go or Python application, nothing really special. All right, let's look at a simple flow. Again, here is the hello world example. So first we define a flow. We define the input schema. And in this case, it has a name. It is a string. And we have a minimum length of 1 character, maximum 100 characters. Hopefully good enough for most names. If not, let me know. And the output schema is a simple string. Here is our input parameter. And we can use it here in the string interpolation to create our prompt. And you could pass in anything that you want. You can pass in integers, numbers, strings, URLs, images, whatever, and then use it in your function in there. So here is this flow in action. So this is our Genkit developer UI, and I want to prefix this is just a developer tool. So this is not the key functionality of Genkit. The key functionality of Genkit is it is a framework, but here this is the developer UI to make it easier for you to work and develop this stuff. So here we are in the flow. I passed in Hamburg as the input parameter, and then the output is the result of the call to the model, and it provides me with a couple of greetings that I could use. So let's try this out. Moin moin, willkommen in Hamburg. Moin, yeah, it works. It's a little bit verbose, right? So moin moin is a little bit too much, I feel. All right, you can compose flows. Here is another flow, or I implemented another flow that is called analyze image flow, and that takes an image and it says what's in the image. And I prompted it to just say, look at the image and give me one word that says which city this is. So here in the greeting by image flow, what happens is I first take the input parameter, which is a URL, send that to the analyze image flow, wait for the result, and then pass the result to the greeting flow, and then greet the people from whatever was on the image, Hamburg, Frankfurt, whatever. So let's watch the recording. So here I have a nice picture. I'll paste that into the flow. Run the flow. And then you get back Hamburg. So that's this one flow. And then let's run the greeting by image flow, which is the composed flow. So again, I paste the same image. And what it does is it first runs the flow to analyze the image, takes the result, pastes it to the generate a greeting flow. And now we get this greeting. So we can view the trace, and that shows us exactly what happened. So here we call the first flow, and we can see the input and the output and a bunch of other parameters like how long it took, when this flow was run, and all of that. And then it goes into calling the model. And once the result comes back, we go into the other flow. So you have this whole traceability and observability even in the developer UI on your local machine. And if you deploy that to a cloud platform, you have that observability in your cloud platform as well. So, and that is why Genkit flows are like a regular old function, but they have superpowers. So, let's see, what's this? Okay. Now, let's look at tool calling with Genkit. So here, I'm trying to get information about what is the time. And the model says, well, dude, I have no idea. And actually, it gives me a time, but obviously that's wrong. So I recorded this late at night yesterday. So now we activate a couple of tools, for example, get current time. And that is a Genkit flow that I implemented. And now here it says, well, here is the actual time. So it can tell me, and that was late at night yesterday or today. So it gives me the actual time. All right, so we now have tools that we can use to make our LLM smarter. And in this case, we can use it to, for example, answer the question, is my flight on time? So we have a tool that can get the time, and it can use that time to then go into the calendar to get the current date, look at what are my plans for today, and then it can also retrieve the flight data from a flight API. But what if I wanted to implement a different application, right? What if I wanted to implement an application that works on my documents to answer questions like, which documents did I work on last week? And probably you're thinking, well, that's easy. We'll just do copy and paste. And you can do that, sure. But what if we had a better way to do that? And instead of copying and pasting, just writing once and reuse. So let's look at the solution for this problem. And the solution is the Model Context Protocol. So Model Context Protocol has a claim, and they say it's the USB port for AI applications. So basically connect everything to everything. So here we have the protocol, and it is a standardized protocol, and it can connect applications like chat interfaces, IDEs, and other AI applications to data and file systems, for example, or to other development tools, or to productivity tools, or to entirely different applications. And you can see that there is a bidirectional flow, so information flows between those two sides. So let's take a look at one example here and look closely at the architecture. So, for example, if you wanted to connect to Google Drive or another file storage provider, you would have to implement what's called an MCP server. So that is the part in the whole architecture that will provide the data. Then you have an MCP host. For example, your chat application. In the beginning, I used Claude Desktop, so that is an MCP host, and it can use multiple MCP clients. And those MCP clients understand how the MCP server works. So to communicate to an MCP server, you also always have to have an MCP client. And then we've got the transport, and typically that is standard I/O. So what you get if you invoke a command line application and you get output back from that. The Model Context Protocol uses that because typically your MCP clients will run inside the host, and the server, I know it sounds a little bit funny, but the server also runs locally on your machine. So the communication between the client and the server happens over standard I/O. Now, if you want to run your server in the cloud, you can also do that. And for that case, you can use server-sent events to communicate between the server that's running in the cloud and your client running on your local machine. So let's build an MCP server. There are a couple of official SDKs for Python, TypeScript, Java, even Kotlin, C#, and even Swift. But today I'm going to show you how to use Genkit to do that. Here is the documentation, and here is your second QR code that talks about how to implement an MCP server. So first of all, quick overview what we need to do. First, we need to install Genkit. Then we need to create a tool like I showed you 5 minutes ago. Then we need to set up an MCP server and register the tool with the server so that the server can expose the tool. And then we need to connect the transport. We're going to use standard I/O for that. And finally, we want to use that new MCP server. So let's do it. First of all, npm install Genkit and the Genkit AI MCP plugin. And then to create a tool for a simple Hello World application, what we'll do is we define a tool. This code should look familiar now to you. This is our metadata that tells Genkit how this function works. We have a name, that is the name of the tool, and this will later appear in our MCP host application. This is a description. This is really important so that the model can understand what this tool is about. Here is our input schema, and again, it is really useful to also describe what these parameters do so that the model can understand, okay, this is the purpose of this parameter. For example, if you want to deal with dates, it is really useful to specify exactly in which format you expect the date to be passed in. Here is the output, so we're just returning a string. And here is the tool function. And this can be anything, right? In this case, we're just transforming the string, but you could call an API, for example. And what I showed you in the beginning, where I had Claude say the greeting for me, that was a tool like this as well. It's that tool was called say, and it basically calls the say command on macOS, and that has a speech synthesizer, and it can generate any output text for you. So setting up the server, just a couple of lines. And the interesting thing is, I didn't have to specify which tools I want to expose because that happens automatically. So Genkit will automatically expose every tool that you've registered, like on the slide before, via this MCP server now. And finally, we'll connect the transport. And as I mentioned, we're going to use standard I/O. Right. So let's look at how this works. Do we have a recording for that? Let's see. Yep. Okay. So this use case here is I want to find out if Lufthansa 1 is on time. So this here is I'm asking the question to the model without the tools. And those tools that you see here, these are exposed by the MCP server now. So now I activate the tools, and the model is able to answer the question. And when I inspect the trace, I can see that, we're calling the model, and the model understands, oh, I need a tool to answer that question. So it makes an API call, gets the details for this flight, arrival time, and so on and so forth. And then it will use that information to generate the final answer. So that is how you can use a tool to power up your model and expose the tool as an MCP server, right? So it's not magic. MCP servers are mostly collections of tools that you expose so that other AI tools can use them. So the same also works for other MCP hosts. So on the slide before, I used the Genkit developer UI, which also is an MCP host. But here we're using Claude, and that also is an MCP host. So here is my calendar. And now I'm using Claude to say, well, can you tell me what's on my calendar today? And I sped it up a little bit, but not too much. So we'll have to wait a little bit while it's thinking, and then it'll make the API call to find out what's on my calendar. And you can see that it pretty accurately says what's on my calendar. And then I ask it to look up the schedule for Lufthansa 1 from Hamburg to Frankfurt. It uses the another tool to look up flight data, which actually goes to a public API, gets the flight data. The next step is I'll ask it to add that flight to my calendar. So now it needs to use the data that it fetched and pass this into another tool, which is the tool to write to my calendar. So that takes a moment. What's happening here? We're just waiting. Yep. Oh yeah, it was not sure when to add this, and I was like, okay, add it for today, please. And the funny thing was, because I recorded this at 5:30 12:30 tonight. That was exactly in the 1 hour where it's not entirely clear where you are, time zone wise, right? So it's it thought we were still yesterday. So here is the calendar entry. And then I think finally I ask it to remove my team meeting because everybody is traveling today. Oh no, I ask it, is the flight on time? So now, and here's the interesting thing. So what you'll see now is it will say something like, I can't answer this question because that API doesn't provide real-time data on those flights for the future. And that is a limitation of the API. Right? It's not a limitation of the MCP protocol itself or my implementation, but it is a problem. Yeah, so the flight data system is showing information from yesterday, which has already landed. And then, unfortunately, the flight tracking system doesn't seem to have real-time data for today's specific flight. So, it's a limitation of the API. And that's also something that you have to keep in mind. All right, let's go to the next slide. Why use MCP? So I think there are many reasons, and I'm just going to give you two. So one of them is you get unified access to APIs and data sources. Now you could say, well, I can access APIs just like that. I can implement a tool, and that is great. You can totally do that. Like I showed you in the beginning, you can write a tool and have a very specific access to a data source. But the cool thing about MCP is that you can make those API accesses reusable. You can build an MCP server for your backend API, right? So for example, if you are a retailer and you want to make pricing information accessible for people to suggest prices for their front store, then you can implement that as an MCP server, and it's easy for people to plug this into their own applications without having to think about, oh, how am I gonna access this specific API? The other reason for using it is access to local apps and APIs, and that is a use case that's typically relevant for content creation. So for example, if you want to remotely control Blender to create 3D objects by specifying how they should look like using natural language, or in our IDEs, right? So if you use any agentic IDE, a lot of the power in those IDEs is coming from the fact that they can connect to other services using MCP servers. But there is one more thing, and let's see if we can do this as a live demo. New chat. So I can now go into this configuration here. So if you are in Claude Desktop, you can go into the settings dialog here and then activate the different tools. So I have got a Keynote MCP server. So what I'm going to do is I'm going to activate all of these, and then I'll say, I need to create a presentation about the model context protocol. Can you please create a technical presentation for that? Thank you. Oh no. I need to create a technical presentation about the model context protocol. Can you please help me? Okay. So, fingers crossed it works, and fingers crossed, oh, internet seems to be fine. All right, so now it says Claude wants to use create presentation from Keynote MCP server, and that's a really important thing that's happening here. So it now asks me for permission because those MCP servers can do scary things like access your file system and delete data, right? So you don't want that. So before any tool gets invoked, you need to approve that, and I'll say I'm going to allow this once. And in the background, you can see that it started a new presentation. And then let's see what it comes up with. It's always a surprise how the structure looks like, but it will now create this presentation. So in the background, you can see it starts creating slides. It starts explaining what the model context protocol is. So I'm going to make this window a little bit smaller, and you can now watch on and see if the tool is doing a good job at explaining how this works. Yep, so you see the MCP host and the client, the server, transport layer. It explains how it works. Common use cases. Yeah. Oh, I didn't talk about data analysis. So that's obviously also a very good use case. Yeah, community ecosystem. That is a very good point as well, right? You know, what I said about creating reusable tools. You create those tools and you can make them available, but other people did so as well. So for example, the access to my calendar, I didn't implement myself, but there is a really good MCP server that can connect to all Google Cloud, Google to calendar and Google Workspace. That's the name. I was looking for the public name. Yeah. So this will go on for a little while now. So I'm going to abort this because you've seen that it works. And now back to my presentation. Oh yeah, that's a recording that I did yesterday, but it worked. That's it.